Hi everyone. So in this video I'm going to talk about the complex form of Fourier series, so let's get right into it. If you remember from the previous lecture of Fourier series, the analyzing integrals a sub n and b sub n, you can see that it's kind of a stupid thing to evaluate two integrals in order to get the signal transformed into the frequency domain. Now the complex form of Fourier series treats this issue by taking advantage of the Euler identity. Okay, so let's say that c sub n equals to 2 over time, integration over time, f of t, e2 minus j 2 pi n f naught t dd. And by Euler identity, we have this complex exponential equals to cosine 2 pi n f naught t minus j sine 2 pi n f naught t. Okay, so this f of t will be distributive and this integration as well. We can simplify this into 2 over time, integration over time, f of t cosine 2 pi n f naught t minus j integration over time f of t sine 2 pi n f naught t dd. Okay, here we have dd as well. Okay, so we can see that this equals to a sub n minus j b sub n. So we have got a sub n and b sub n just by evaluating a single integral. Now this j is very important. It makes sure that there will be no any kind of interaction between the magnitude of the cosinusoid components and the magnitude of the sinusoid components. For example, if you got c sub 5 equals to 5 minus j 17, so you're sure that this 5 equals to the magnitude of the cosinusoid component and the 17 equals to the magnitude of the sinusoid component. Okay, now let's move on and see how should we modify the synthesizing formula. We had earlier that f of t equals to summation from n equals 1 to infinity a sub n times cosine 2 pi n f naught t plus summation from n equals 1 to infinity b sub n sine 2 pi n f naught t plus a naught. Okay, so this formula is written in terms of a sub n and b sub n. We need to modify it to fit the new definition of c sub n. We have c sub n equals to a sub n minus j b sub n. So the magnitude of the cosinusoid component and the magnitudes of the sinusoid components are encoded in somehow inside c sub n. So what I'm gonna do is multiply c sub n by a complex exponential e to j 2 pi n f naught t. So since c sub n includes a sub n and b sub n, and the e to j 2 pi n f naught t includes cosine 2 pi n f naught t and sine 2 pi n f naught t, I'm going to sum this from n equals 1 to infinity, and let's check if this really equals to f of t. So we have c sub n is a n minus j b n, and e to j 2 pi n f naught t is cosine 2 pi n f naught t plus j sine 2 pi n f naught t. So we have summation from n equals 1 to infinity a sub n by cosine 2 pi n f naught t and a sub n plus j a sub n sine 2 pi n f naught t minus j b sub n cosine 2 pi n f naught t, and j times j is minus 1, so we have plus b sub n sine 2 pi n f naught t. So as for this a sub n cosine 2 pi n f naught t, here is it, and for b sub n multiplied by sine 2 pi n f naught t, here is it. The bad news is that these complex terms, remember in the end we need to get f of t, which is a real function. So we need to get rid of these complex terms. The idea is to add a complex conjugate version of this term. So we add a sub n cosine 2 pi n f naught t minus j a sub n sine 2 pi n f naught t plus j b sub n cosine 2 pi n f naught t plus b sub n sine 2 pi n f naught t. So a sub n by cosine and b sub n multiplied by sine are the real parts of this complex term, and this and this are the complex parts. So I have changed the sign of these two terms, so I got the complex conjugate version of this term. So when we add these two terms, we get this and this cancelled. This and this will be cancelled as well. So we treated this issue. So we need to add another summation from n equals 1 to infinity contains the complex conjugate version of this. So c sub n conjugate e2 minus j 2 pi n f naught t. However, when we add this real part with this, we get 2p sub n sine 2 pi n f naught t, and this we get 2a sub n cosine 2 pi n f naught t, which is not true. There is no 2 factor here and here. So we need to divide this definition by 2. Or we can modify the definition of c sub n that we defined earlier. So we need to we can actually divide this definition by 2. So this will be cancelled, and the new definition of c sub n fits the formula of synthesizing components we obtained here. So in order to summarize that, we say that the new definition of c sub n is 1 over time, not 2 over time, integration over time, f of t e2 minus j2 pi n f naught t dd, and the synthesizing formula is f of t equals to summation from n equals 1 to infinity for c sub n e2 j2 pi n f naught t, and the other complex conjugate term is summation from n equals 1 to infinity for c sub n conjugate e2 minus j2 pi n f naught t. Keep in mind that this equals to a sub n minus jb sub n divided by 2. Now there's one more simplification step that we can do to this synthesizing formula. For example, if n equals 5 in this summation, you get c5 conjugate multiplied by e2 minus j2 pi times 5f naught t. In this summation, you get c sub 5 multiplied by e2 j2 pi times 5f naught t. Now you can see that you can get this complex exponential just by substituting n equals minus 5 in this complex exponential. So if n equals minus 5, you get e2 minus j2 pi times 5f naught t. You get this sign. This means that we can get rid of this summation and substitute these terms just by extending the range of this summation from minus infinity to plus infinity. So we can say that f of t equals to summation from n equals minus infinity to plus infinity c sub n e to j 2 pi n f naught t. Now the summation can be extended to 3 summations actually. One from minus infinity to minus 1, and one from 1 to infinity plus c naught. Now this part of the summation gives you the terms given by this neglected part of the original definition of f of t. However, we need to make sure that c5 conjugate is equal to c minus 5. So is c minus 5 equals to c plus 5 conjugate? We need to make sure if this is true such that we can get rid of this summation. So here's the definition of c sub n. If you substitute n equals minus 5, okay, and here's n, then you get e2 plus j 2 pi and f naught t. So this is equivalent if someone is conjugating this thing. So it's obvious that c sub n conjugate equals to c minus n. So when negative n values will be substituted in c sub n, this is equivalent for substituting positive n values in c sub n conjugate. We also shouldn't forget c naught. You can see in the original synthesizing formula we have a naught. Okay, you can see that c naught is equivalent to a naught from the definition over here. So this is another advantage for the complex form. It unifies a single formula for all the values of coefficients. So to summarize, we say c sub n equals to 1 over time integration over time f of t e2 minus j 2 pi n f naught t dt, and f of t equals to summation from n equals minus infinity to plus infinity c sub n e2 plus j 2 pi n f naught t. So you can see that we have a single formula that enables you to find all coefficients. It equals to a sub n minus j b sub n divided by 2. So the three integrals are evaluated, which are the a sub n integral and b sub n and a naught. You can see that if we substitute 0, we get c naught equals to a naught minus j b naught. B naught is always 0, divided by 2. So the complex form is very smart, it's very useful, it compensates three integrals, and it also presents a very good introduction into the Fourier transform.